sheet with you every single day so that you can use it for when you're doing your notes, when you're doing your classwork, and when you're doing your homework. The ones that we're going to focus on first are going to be these right here. The reciprocal and ratio, which we've done before. Pythagorean is going to be a big one that you need to know. And then the even and odd, you don't see a lot of that. Actually, I don't think the tangent and cotangent's missing on your paper. But tangent of negative x is equal to negative tangent of x, and cotangent of negative x. So as far as simplifying goes, you never want a negative inside the parentheses. You can have a negative out in front because it's just a negative value, but for the even and odd identities, if you have a negative in the parentheses, that's something you want to get out, and this right side is the simplified version. Notice sine and tangent and their reciprocals go from negative inside to negative outside. Cosine and secant are the only ones where it's negative in, and that turns into positive. And I can show you an example of that at the end today if you want to know how come that happens. We can plug values in off our unit circle, and you can see why that happens if you want to do that later. This is not on your notes, but this is an important concept that you need to know. It's kind of an Algebra 1 concept, being able to rearrange a problem. Like before you learned about y equals mx plus b, you had problems where you had to manipulate an equation. You had to solve for a certain variable. This is the same thing. Okay, we have sine squared a plus cosine squared a equals 1. So that's a Pythagorean identity. We want to change that to make it look like something else. Well, we can move things left and right and it still be equal. I could move the cosine to the other side and make this sine squared a equals 1 minus cosine squared a, still the Pythagorean identity, which you'll see as you work these problems, you're going to have to manipulate them. We can't change it. We can't take the square root of that. That's not something that's even possible to be done, but we can manipulate it. We could also change this to cosine squared a equals 1 minus sine squared a. Those three you'll see a lot as far as that order that it goes. Now, the signs are very important. We could change this at least 2 other ways also. I could switch the cosine squared a and the 1. I could say sine squared a minus 1. If I bring the 1 to the left, it becomes negative, and I bring the cosine over, equals negative cosine squared a. That's another way I could manipulate that equation. I could also say cosine squared a minus 1 equals negative sine squared a. So just different ways you can manipulate that. The sign matters. Notice up here, sine squared a equals 1 minus cosine squared. Down here, negative sine squared equals cosine squared minus 1. Those signs matter. You can't just see a sine and a cosine together and say it equals 1. It has to be sine squared plus cosine squared. If there's a minus right there, that's not a Pythagorean identity. It's an identity that we'll get to eventually, but it is not a Pythagorean identity. So you have to be able to manipulate those and look at the problem. Again, this is very different. There's not steps. You just have to look at your identities and be able to rearrange them to try to simplify. And by simplifying, you're trying to get it to either be one term, no fractions, a couple things that you're looking for as far as simplifying goes. All right, so these first few examples is just kind of showing you how you use the identities to change it. There are different options. There's not always just one way to do it. Sometimes you want to change it, sometimes you want to leave it there. It just depends on the problem. Again, there's no steps to say this is always what you do. So if we're looking at cotangent x, there's a couple different ways we could write that. We could look at our identities and we could rewrite cotangent x as cosine x over sine x. That might be something we need to do. Or we could also write that as 1 over tangent x. That might be something we need to do. We won't know until we get to the problem that is either a simplify or a proof. But that's two different ways that we can change cotangent x. Now this next one, cosine squared y. What cosine squared y means is cosine y times cosine y. Alright, notice the y is not being squared. Cosine y is being squared. Cosine y times cosine y. So we could write that a couple different ways also. We could change this to 1 over secant squared y, or we could change it to 1 minus sine squared y, because, again, of our Pythagorean identities. And it just depends on the problem, the simplify or the proof problem, which one of those we're going to use. One of you might choose to change it to 1 over secant squared. One of you might decide to change it to 1 minus sine squared. They might both be right. This one might get you to the answer in 1 or 2 steps. Changing it here might be 5 or 6 steps, or vice versa. Or maybe one of them doesn't work, and then you have to erase and go back and use something different. Okay, there is no way to for sure know how to start these problems. You just have to start it using the identities and then work your way till you get to a somewhat simplified answer. Now this next one, sine negative x. Again, that is our even-odd identities. We never want a negative in the parentheses, so we need to simplify that. The right side is the simplified version. And so that is going to equal negative sine x. From negative sine x, we can make that negative 1 over cosecant x. Again, that's not simplified, but that's just another way to change it. Tangent squared x, we could do that a couple different ways. We could make that sine squared x over cosine squared x. Or, if we look at our identity right here, we look at our Pythagorean identities, they include all 6 trig functions. We look at the tangent squared. So if I want to put tangent squared by itself, I need to bring the 1 over to the other side. So I could also say tangent squared x equals secant squared x minus 1. So just different ways that you can change the problem. And it depends on the problem how you want to change it. Questions on those for just changing using the identities? Alright, and then this bottom part comes up a lot, just reminding you what these are called. So 3 times 1/3, what are those called? 3 and 1/3. Reciprocals, okay? They're called reciprocals. And when you multiply reciprocals, what do you always get? 1. So anytime you multiply reciprocals, you get 1. That works with trig also. So it works with numbers, which is how you started a long time ago in math. 3 times 1/3, 2/3 times 3/2. Then you went to variables. You had x's. X times 1 over x is 1. And now we have words. Sine and cosecant are reciprocals. So sine times cosecant is also equal to 1. The way you would prove that, so eventually we'll get to the proof of that, the way that you prove that is sine of theta. Cosecant we could rewrite as 1 over sine of theta, which gives us sine of theta over sine of theta, which equals 1. Now, multiplying reciprocals, that is not something that you ever have to show me how you got that. Okay, that is something that we expect you to know, just like we expect you to know that 3 times 1/3 is 1. We don't have to see 3 over 3 and then 3 divided by 3 is 1. Same thing with this. If showing it helps you, then do that. But anytime you multiply sine times cosecant, or secant times cosine, or tangent times cotangent, it's always going to be 1 because they're reciprocals. And that works the same if they're squared. If I change this to sine squared theta times cosecant squared theta, those also are reciprocals, which equals 1. So notice the tangent squared. and the cosine squared. We can do that to the reciprocal and ratio. We can square those and it be the same. I can change this to tangent squared, sine squared, cosine squared. I could change this to cotangent cubed, cubed, and cubed. We cannot do that with the Pythagorean identities. We can manipulate them, move things from one side of the equals to the other, but we cannot say sine theta plus cosine theta equals 1. That is not something we can do, because we can't just take the square root of something with a plus sign. We can do that with everything else, but not with the Pythagorean. These are the Pythagorean identities, and the only thing you can do is move things from the left and right of the equal sign. All right, so let's look at a couple of these examples. So it says to simplify sine x times cotangent of x. Now, you don't always change everything. So you've got to look at it and see which one should I change. Well, I have to think about it. Sine, the only way I can rewrite sine is 1 over cosecant, but I can write cotangent in terms of sine and cosine. So I want to leave that sine x. I don't want to move it. And I'm going to change cotangent to cosine x over sine x. So now you can see how, because I did that, the sine x on top cancels with the sine x on bottom, and I'm left with cosine x. I don't have a fraction, and I have a single term. When you don't have a fraction and you have a single term with simplifying, most of the time that's how you know that you are finished. If you have a fraction, you always want to change it to not be a fraction using the ratio or reciprocal ID. If you have two terms, you want to look at your Pythagorean identities. When it has a plus or minus 1 or 2 of the trig functions added together, the sine and the cosine go together, the secant and the tangent go together, the cotangent and the cosecant go together. If you have two terms with some kind of 1 involved, then you want to look at that and try to simplify it down to a single term. All right, here we have cosecant divided by secant. That's a fraction. We can't have a fraction, so we're going to have to do something to that. Because they're both reciprocals, I'm going to change them both. Another thing with this unit, there's not only one way to get to the answer. There is usually one answer. Sometimes there's a couple answers, and we'll get to those eventually. There's different ways to write it simplified, but number one, kind of the only way to get to that answer. So here, I'm going to change cosecant to 1 over sine x and secant to 1 over cosine x. And now I have a fraction and a fraction. I cannot divide fractions. I have to multiply by the reciprocal. So 1 over sine x times the reciprocal, cosine x over 1. Now I'm going to show an extra step right here that's not necessary for some of you. So now we end up with cosine x over sine x, which is still a fraction, so we've got to get rid of that fraction. So our answer is cotangent x. Be sure when you're working these simplifying problems, you show steps, okay? Show at least 2 of these 3 steps to get to the answer, because when we start doing the proofs, you will have to show every single step. And then you're going to have to say, why did you do that? So the reasons, you're going to give reasons. How did we get from here to here? Well, we used our reciprocal ID. How did we get from here to here? We divided or multiplied by the reciprocal. How did we get from here to here? We multiplied. From here to here, we use the ratio ID. So that when we say state your reasons, you're just using, did you add, subtract, divide, multiply, factor, cancel, or use some sort of ID? All right, when you have adding and subtracting problems, one thing that you're going to, all your algebra skills that you've learned, factoring is one thing that you need to consider when you have adding and subtracting problems. First, you want to look, is there an identity when there's an add or subtract? Another thing you want to look at is, can I factor? This problem, you could change and simplify and then go from there, or when I look at this problem, I see each term has a tangent. Because each term has a tangent, I'm going to factor that out. So if I factor out a tangent theta, because I had 3, I'm left with tangent squared theta minus secant squared times tangent, so that leaves us with a secant squared theta. And then I'm going to look in my parentheses. Can I make 2 terms into 1? You always want to try to change 2 terms into 1. So go back and look at your identities. We look at the secant and tangent identity, and this was tangent minus secant, right? Inside there, tangent squared minus secant squared. So if I tried to manipulate this to be tangent squared minus secant squared, that means I'd have to bring the secant squared to the left. When the 1 goes to the right, it becomes -1. So in the parentheses, this becomes -1. But we still have our tangent theta. Tangent theta times -1 is negative tangent theta. So we don't have a fraction and we have a single term. When you don't have a fraction and you have a single term, you know for sure you're done. Sometimes you can have more than one term. If it's not a Pythagorean identity and you have more than one term, it's okay. You always want to check with your Pythagorean identities. If your 2 terms do not turn into a Pythagorean identity, then your 2 terms is okay. All right, and then this last one has to do with the even-odd identities. Very important on this one that you don't change it. This is multiplying. 3 trig values right here, and they're all being multiplied by each other. So don't turn a multiplying problem into an add and subtract problem. It's very easy to do if you don't use the correct symbols along the way. All right, so first we have sine of -x. When we look at our even-odd identities, that turns into negative sine x. Cosine of -x, again, you just look on your identity sheet, turns into just cosine of x. And tangent of x is just tangent of x. It's not tangent of -x, so tangent of x just stays. It's just a regular trig value right there. We don't change it because it's not tangent of -x. It's just tangent x. All right, so now we have sine, we have cosine, and we have tangent. Most of the time when you have just your regular sine or cosine, with a tangent you want to leave it as it is. So I'm going to leave this negative sine x times cosine x. Tangent is sine x over cosine x. Because of your even-odd identities. You have that identity sheet? No? Do you or no? Yes, so just look at your identity sheet. So that's why you need that identity sheet with you all the time. So right here, cosine of -x equals cosine x. And again, if you want me to show you why that happens with the different functions, like I'll plug values in when we're done and show you why that happens. Okay, I can prove that according to putting values in why it turns out to be that way. All right, so now if you want to make that over 1, you can. It's up to you. You don't have to, but some of you, if you don't write that neat, it might be helpful to do that so you don't get confused on what's on top and what's on bottom. So notice we have a cosine in the numerator and a cosine in the denominator, so those cancel. Both of these signs are in the numerator. So sine x times sine x. The x's aren't being squared, the sine x is being squared. So negative times positive is negative, and the way we write that is sine squared x. So there is your answer. It is very important that you do not square the x. You square the sine of x is being squared, not x. And you can think of it like if I plugged in, let's say I plugged in 30 degrees for x. If I say find sine of 30 degrees and square it versus sine of 30 squared. So sine of 30 degrees is 1/2. 1/2 squared equals 1/4. But if I do sine of 30 degrees squared, that's sine of 900 degrees. It's a much different answer. So again, you're squaring the function, you're not squaring the x or y or theta value. Another thing that's important in this unit is to keep the variable that's given, the x, the theta, the y, the capital A, whatever it is. We're going to change it up all the time, that you don't change that. You have to use the variable that is given. And